All right, guys. Good morning. Welcome back. This is part two of chapter seven, configuring and verifying switch interfaces. Now we left off, we were talking about some very cool stuff. We were talking about fast link pulses, auto MDIX. We revisited that from chapter two. We were talking about interpreting auto negotiation, right? Negotiation having an IEEE standard. We're talking about duplex mismatch and a lot of cool things. We were also, to be a little bit more meticulous, we were talking about auto negotiation in the working state, right? And in the broken state, right? Of how it's not supposed to look like. We covered configuring auto negotiation, speed, and duplex. And this is only regarding Cisco switches. We also covered some verifying commands, show interfaces status, what to look for, a couple of the clues, right? And a couple of these things were key topics. So, of course, the Cisco Press is telling you, hey, I'm showing you what this looks like. So, whenever you take the exam, this is what you have to be ready for. Okay. Um, so we covered a lot of stuff. I wanted to end class on time. I didn't want it to go beyond an hour. I feel like if it goes beyond an hour and we're covering theory, um, that then of course I'll lose you. And I don't want to lose you. So that's why I went ahead and cut it short. So we're going to continue on with the chapter, um, and then we'll be good to go. Okay. So we left off on the section that starts managing switch interface configuration, right? So this section is going to go ahead and cover some additional interface subcommands, right? Um, More specifically, description and shutdown. Okay. Um, so description, it gives you the ability to document an interface, right? Um, about any interface, right? And the second enables you, which is shutdown, it enables you to um, disable and enable, okay, the interface, right? Administratively. I got to make sure I say that word administratively because that is what you're going to see within the switch. Okay. All right. So let's talk about it, right? So the description command, right? Um, you can use the description subcommand within the context of an interface in global configuration mode. It basically lets you add a text description to the interface, right? Use your keyboard characters, include spaces, um, and just for your own knowledge, Cisco switches, they support 200 characters for description text. Okay. So for this example, of course, you see some of the mechanics in the process, right? So we went in gigabit, let me get my pencil, right? Gigabit Ethernet, 1/0/1, right? We went ahead and that's a terrible drawing. We went ahead and added description, right? So description link to PC1 using auto negotiation, right? So we got spaces, we got, uppercase, lowercase, we got commas. There's really not any limits besides the 200 character limit. And how can we verify? Right? So we can verify it two ways, right? So as you guys can see, take my pencil out again, we can use the show interface, right? The name of the interface and the status command. So the show interface status command, right? And we'll see an abbreviated omitted version of our our description, right? It's going to be under the column name, okay? Whenever we use that verification command, right? So it's going to cut off roughly in the middle, right? But how can we look at the entire thing, right? We can use either a show interface, right? That's going to show us most of it, right? If as long as it's not omitted, right? Or we could just always use a show run interface, et cetera, et cetera. Okay, let's keep going. All right. So we also need to talk about, um, of course, configuring multiple interfaces, right? Um, Example 710, it goes over how to configure, right? Configure the same subcommand on multiple interfaces simultaneously, right? So for example, right? We have interface for, for this screenshot, interface range, gigabit 1/0/2, um, to, through, I apologize, through interface 10, right? And so you see, right? Let me get the pencil out. I think that's better for you guys to track. So we have the interface range command. It's telling us the interfaces that it's, that it's attacking. And now we see that this changed. So now it's config IF, which is shortened for interface range, right? And so we're going to go ahead and apply this description, right? Interface not in use, right? So if we go ahead and go to verify, right? If we go to verify this, now we see that, hey, gigabit 1/0/1/0/2, gigabit 1/0/3, right? It has the same description, right? Because um, we use that range command, and you also see it here as well. Okay, so this is how the iOS expands the subcommands typed after using the interface range command. Right, pretty useful tool. It saves some time. You don't have to go to each interface. That can be time consuming. So again, you can always use show running config to go ahead and verify the configuration of your interfaces. Okay, let's talk about administratively controlling interface state with shutdown, right? As you guys might know, network engineers need a way to enable and disable an interface using a command, right? Um, so basically on and off switch, right? So Cisco, they created this command, which is called shutdown, right? To disable an interface, okay? Right? To enable the interface, right? In reverse, you can use the no shutdown command, okay? And that will enable interface, right? So, um, I'm sorry, guys, I had drew a blank, but yes, shutdown disables an interface. Um, no shutdown enables an interface. And whenever you use these shutdown commands, as I said earlier, you are administratively disabling an interface. Okay. As you guys can see in this example, right? Gigabit interface, gigabit Ethernet interface, 1/0/1. We use a shutdown command, right? And we see our syslog, right? It outputs to the console and we see that it's administratively down. Okay. Then we get the second syslog message that says, hey, line protocol, right? Layer 2, it changed to down. Okay. All right, let's keep going. Okay. How does it look like with some of our verification commands, right? So if we do a show interface status after we issue a shutdown command, right? Now the status is going to be disabled. Okay. And now if we do a show interface in the interface name, we'll see layer 1. Of course, that first line is going to say gigabit Ethernet 1/0/1 is administratively down. And now line protocol is going to be stated as disabled. Okay. All right. Let's move forward. Right. Let's talk about removing configuration with the no command. Right. So the chapters in part 2 of this of the book, right? Because we're going off of and to credit Cisco Press, where we are going off of the CCNA 200-301 official cert guide, volume 1, right? And I'm actually using the official cert guide library. Okay. So you know, it goes over some topics about LAN switches, especially in part 2 of the book, right? And you'll learn about, the CLI, especially this, on switches, and you'll get some examples, right? For any iOS configuration command that you might configure, you also need to consider this, right? How can you remove that configuration, right? With some iOS configuration commands, not all of them, right? You can revert to the default setting by issuing just a simple no and then the command. Okay. So if I put in the command shutdown, I simply, if I want to remove that, I just put no, then the command shutdown. If I want to configure the speed, I configure the speed. If I want to remove the manual configuration of the speed, I just say no speed. Okay. That's going to revert it back to the default setting, which is speed auto, right? Same thing for duplex. If I say no duplex, the configuration is going to revert it back to its default setting, which is duplex auto. Okay. All right. So here's some examples, right? We see here, right? We have our configuration, right? We have our description, we have our speed, we have our duplex, and we have shutdown configured, right? Looks clean. Okay. If this is what whoever configured this wanted, this looks clean, right? Let's say we wanted to remove some of these configuration settings under the interface. We do no, we do no, we do no, we do no, right? And so now, right, up until now, I've shown you guys have seen whenever we configure something and then when we reverse that configuration, right? And you guys also know what it looks like whenever an interface is in its default state. So to confirm, to verify that once removing our specific configurations from our interface, if we go down to if we run a show run config, we can verify here that none of our configuration is in place. That means it is back to its default state. Okay. So just want to note, right? The show running config, the startup config, those commands typically do not display default configuration settings, right? This is why you will see the absence of interface subcommands under an interface, right? That means that all possible subcommands use default values, right? Like I shared with you guys before. If you want to see, right? If you are intrigued, and I push you guys to strive after it. If you want to see configured and default settings, you can use the command show run config all. Now, be warned, be warned. The show running config all commands list a lot of commands, about 10 times the output of the show running config command. Okay? So just remember that. All right, let's keep going. So now we're going to go ahead and move on to analyzing switch interface status and statistics. Okay? So this is the final section within chapter 7, right? Um, and we're just going to talk about how interfaces actually work. We're going to be a little bit meticulous about this. Okay. We're going to talk about some cases, in which an interface um, is working but not working well or not working at all. Right. Let's go ahead and tackle interface status codes. Right. Cisco switches use two different sets of interface status codes. Right. The switch show interfaces and show interface description command list a two code status name, right? A two code status named the line status and the protocol status. Okay. Together, these two status values identify the state of the interface. Generally, the line status refers to whether layer one standard works, while the protocol status refers to whether layer two works. Okay. And to note, right? The book that we're using for our studies for this journey, what have you, the book refers to two status codes in shorthand by just listing the two codes with a slash between them, such as up up or down down. So let's go over, right? Let's go over the LAN switch status codes. Okay. If we went ahead and ran a show interface status, right? Show interfaces or show interface description, right? Um, because a lot of them are going to have different status codes or what have you, right? Right, if we ran a show interface status, right, under the columns, you'll go ahead and see it'll say it connected, right? It'll say connected for working interface. It wouldn't say up, up, or down, down. While if we go ahead and use the show interfaces or show interface description, then we're going to go ahead and see that, in that column A, the interface is listed in a up, up state or a down, down state or up, down state. Okay. So let's talk about these. Let's go ahead and go over this table, right? And let's go over the status codes, right? So first, first row, right? Line status is administratively down. Protocol status is down, right? Interface status is disabled. And the typical root cause is the shutdown command is configured on the interface. Okay, right? Self-explanatory, right? Line status, if we go to second row, line status is down, right? The protocol status is down. And now we have the interface status not connect, right? You can go ahead and translate that to not connect, right? So what that tells us is the root cause for that one is can be a couple of things. It can be no cable. It can also be bad cable. Okay, this is why layer one is important for troubleshooting. It can be wrong cable pinouts with MDIX. And let me go ahead and erase that. I don't think you guys can see that. Wrong cable pinouts with MDIX, auto MDIX, disabled. Okay, speed mismatch. The neighboring device is either A, powered off, B, shut down, or C, error disabled. So guys, this is, I love this section, especially this row for the down down state. This is a prime example of why using the OSI model for your troubleshooting method, okay, is the main approach you want to take whenever troubleshooting, okay? Because you're checking things at layer one, then you're going up from a network standpoint, right? You can go bottom up or top down. But to make it easier, I recommend, right? Dave recommends doing bottom up. Layer one, check everything. You get all the hard work out. Then when you move to layer two, then layer three, it'll be much easier trying to figure out if there's something at layer three going on. Okay? All right. Thank you, Cisco, for showing that. So now we go to the third row, right? We got a line status of up, the protocol status is down, and we got a interface status of not connected. Not expected on LAN switch physical interfaces, right? So you'll rarely see this, okay? There is, now let me go ahead and sidestep Cisco for a second. There is a reason why this would show up. It's not listed for the exam here. But if you guys are interested, reach out. I'll go ahead and I'd love to figure that out and recreate it for you guys. I will find a technical article that would showcase this status combo, this line status and protocol status combo, okay, and find the root cause as to why this is the case. Okay, let's go to row four, right? We got down and we got down and we have error disabled. Okay, typical root cause is port security or other feature that has disabled the local interface. Typically, you can verify this by doing a show log reverse to make it easy so we can show you much of the recent, depending on if your switch or your Cisco device is in production. You do a show log reverse on some of the newer code software. If you're using some of the older software to lab, it may not have the show log in reverse. Either way, doing a show log, it'll show you if the interface is disabled. Okay. And last but not least, the final row 5, we got up, we got connected. This is what we like to see. And a typical root cause is the interface is working. Okay? All right. Hopefully that made sense. I do want to talk about something here. Before we move on to the next section, right? Is examining the non-connected state for a moment, right? Note that, and you guys saw it within the down state, right? You have to take note that this state has many causes, and you guys want to recreate this within your physical lab, right? I love packet tracing, but please recreate this in your physical lab. For example, the state includes the most obvious cases like a missing or broken cable, right? Um, but right, there are some examples of root causes of cabling problems that result in a non-connect state that include, right? Let me get my pencil out so you guys can follow me. The installation of any equipment that uses electricity, I apologize, even non-IT equipment can interfere with the transmission on the cabling and link fail. Okay. Number two, the cable could be damaged. For example, if it lies under the carpet, the electrical signal can eventually degrade if the user's chair is just squashing the cable, right? You have to take that into consideration, guys. It's layer one for a reason. It's called physical for a reason. There are many things that can mess up your LAN, and never say never. I've troubleshooted for hours, and I'm someone who, whenever I got my certification, I was like, nope, I don't have to worry about this. And this wasn't it within the ICND days, right? And that's when I got my certification. You wouldn't see this. What you would see is just the book showing us the official cert guide showing you what it, you know, theory and not really real world examples. This is a real world example. You're trying to troubleshoot for hours. Why is this cable not working? Why is this cable not working? It's under somebody's desk. Over 5 to 10 years, they've been rolling back and forth. They finally crushed the actual cable, right? Now the cable is not working. And last but not least, right? Although optical cables do not suffer from EMI, someone can try to be helpful. Okay? Someone can try to be helpful and move a fiber optic cable out of the way by bending it too much. A bend into too tight a shape can prevent the cable from transmitting bits. This is called macro bending. Guys, I had this happen. Um, yeah, I had this happen while I was actually working on one of my first projects as a network engineer. Um, I'm sorry, not one of my first projects. One of the several projects of my new job as a network engineer. Um, and it's been a while since that. Whenever you're in a data center, whenever you're implementing something, my advice will always be, and I had to learn this from my boss, is that there may be a lot of people in the data center. You may be in a state where you want to teach a lot of people, and everybody's trying to be helpful. Sometimes it is not good to have multiple people working on fiber, especially optical, especially fiber. You want one person, one or two people at best, working on that at a time. Everybody can look, but it is very important that you let people know, hey, can't have a lot of people, um, can't have a lot of people trying to be helpful. Fiber optic is very sensitive, and one small bend, right, too tight of a shape, one bending, it can prevent the fiber optic cable from transmitting bits. And these fiber optic cables are capable of transmitting data at high speeds. Imagine if you're in your data center and you do that, you could significantly impact the business. So keep that in mind. Okay. Now let's go ahead and move on to talking about the duplex mismatch issue. Okay. We've talked about, you know, if we see the status being up, right? And that means everything works, right? Yes, we want our switches in that state. However, we can see that the status is up. That doesn't mean there can be a duplex mismatch. Okay, here's what I mean. Right? If the devices on the ends of the link use the same physical layer standard with the working cable, the interface reach an up state. However, the endpoints can also have an opposite duplex setting, duplex mismatch. That's the condition, with full on one side and half on the other. The interfaces remain up, and data flows. However, the device that uses half duplex experiences unnecessary errors and retransmissions. Okay? You always need to remember, right, the recommendation by now. Avoid problems like duplex mismatches by using auto negotiations on both devices on each link. However, because the CCNA exam topics have mentioned the duplex mismatch problem for most of its history, take a closer look at how the duplex mismatch can occur. Okay? I think we covered it. I think we covered a lot of what the parallel detection condition looks like. I think you guys know what happens, right? So, but let's go over this logic here in this picture, right? So figure 7-7, right? So let's go over this logic, right? Switch two, right? We're looking at switch two, right? So switch two sets its speed, right? That administrator there sets the speeds to 100 and sets the duplex to full manually, right? Switch to disables auto negotiation. What does that do? When you disable auto negotiation, what you also disable is you disable FLP's fast link pulse messages from being sent. Okay? Remember that, right? So now that fast link messages aren't being sent, are not being sent, I'm sorry, from switch two. Switch one moves on to use auto negotiation in the parallel detection condition, meaning that it's going to read, right? It's going to sense that switch two is using 100 megabits per second. What does that mean? That means the switch is going to say, hey, based on the IEEE auto negotiation parallel detection rules, if the speed is between 10 and 100, I need to set the interface to half duplex. If it was above 100, I will go ahead and set it to full. But if it's 10 or 100, it is going to be half duplex. Okay? Cisco is recommending that, okay, to not have that parallel detection condition come into effect. Make sure you configure on both sides manually your speeds in duplex, or you just leave auto negotiation on for both sides. Okay. All right. Let's keep going. Okay. Let's talk about, and this is the last piece of the chapter. Let's talk about common layer one problems on working interfaces. All right. Um, and this is one of my favorite parts, right? When the interfaces reaches the connected up state, right? That's the state that we want. Okay. The switch considers the interface to be working. The switch, of course, tries to use the interface, and at the same time, the switch keeps various interface counters. Okay. These interface counters can help identify problems that can occur through the interface reaches a connected state, like issues related to the just completed duplex mismatch problem. This section explains some of the related concepts and a few most common problems. Okay, let's dive in. Let's dive in. So let's say we have two devices connected, right? We have one device, right, that might receive a frame, right, whose bits have changed values, right, whenever the physical transmission has problems. These frames do not pass the error detection logic has implemented within the FCS field, right? Talking about layer two now, right? The frame check sequence. It doesn't pass, right? The error detection logic has implemented in the FCS field, right? We covered that in chapter two. The receiving device, right, discards the frame and counts it as an input error. Okay? Cisco switch lists this error as a CRC error. Right here. CRC error. Cycle redundancy check. Right? What is that? Right? This is a term that's related to how the frame check sequence does an algorithm, right? Does some math and detects an error. Okay? We see the term and we see a number associated, right? This is the errors, right? This is the context, and that's the number associated with it, right? The numbers of input and the CSC errors are just a few counters in the output of the show interfaces command, right? Here's the thing that everybody has a network engineer that you just learn throughout time, network technician, system admin, whomever. That this is going to be the challenge. The challenge here is to decide which counters you need to think about, which ones show that a problem is happening, and which ones are normal and of no concern. Okay. All right. On my screen, you guys can see, and I'm not going to go ahead and go over it. I want you guys to cover it. Read up on this, okay? But remember, you determine whenever you're troubleshooting what's errors and what's not errors. But to do that, you need to know the context and what all of these mean. For the exam to the right, we'll cover that first. This is what you need to know for the exam. You guys being future engineers that are watching this video, trying to get your CCNA, strive to learn all of this and don't learn nothing less. Okay? All right. So, with that being said, chapter 7 is finished. Remember to go ahead and do a chapter review, go over, of course, table 7-3, then the chapter, go over that, say table 7.4, go over the key topics, go over some of the key terms, do the labs. If you have the official Cert Guide library, you bought that bundle, please do the labs. Also, look on Udemy for some like Neil Anderson. He has amazing labs that get to the concept. Please do that. Do go over some command references in table 7 -5, 7-6, and you are good to go. We will have a lab to support this. All right. Thank you guys.